Hi, Lou Peterson here with PulseLarsen Antenna. Here we are in our Vancouver facility. We're going to do a plant tour. We have two factories, one here in Vancouver, Washington, and one in Suzhou, China. But we're going to do the tour here in Vancouver, Washington. This is the office area. You'll see we have the manager offices here. We've got quite a few cubicles. We've got a conference room right over here. The office contains marketing, sales, engineering, field application engineers. We've got quality. We've got operations. We've got procurement. Before we go out to production, I want to show you a new piece of equipment we got over here. It's a 3D printer. It's a great piece of equipment for making prototype parts. You can make plastic radomes, antenna bases, all kinds of parts that are used to design antennas. Come on out to production. Our production area is divided in half. One half is an ESD sensitive area for products that are sensitive to ESD, static discharge. The other half is non-ESD. We're going to have a quick look at some of the ESD products that we're building here. Let me put on my jacket. Our operators are dressed in clothing that protects the product from any type of static discharge. They're grounded to a grounding system that's calibrated and checked every month. The product is so small that they work through a microscope, soldering coil leads to a circuit board. This is our HF line. We see what we call a stealth blade antenna. It's basically a circuit board wired to a coaxial cable, and a shrink tube is shrunk around the circuit board and it's encapsulated shrink tube to seal the product and make it weather resistant. The radomes are a very rugged outdoor antenna that can handle all kinds of weather environments, hot, cold, wet, salt spray, all kinds of stuff. They're a very durable antenna. All we see right now is just a radome cover. There's typically a base coil at the bottom and a cap glued at the top. Low profiles are cool. They go onto what we call an Enamo mount. This bottom is made to screw onto an Enamo antenna mount. There's a circuit board that's attached, and the feed point is soldered to this circuit board. This is an 800, 900 megahertz low profile antenna. It also gets a radome over the top of it. This will be glued on in the end. There will be a foam tape put on the bottom for a good water seal, and this basically is a nice low-profile antenna that can go on to a lot of vehicles. When it goes through the car wash, you don't have to remove the antenna. It's very durable, very high-performance antenna. I have here a completed radome. We were looking at the radome too, but this is a finished product. You can see at the base is the matching coil, and then there's an antenna rod that goes throughout the length of the radome. We're going to go look at where these coils are made right now. Come on with me to the coil line. This is our coil line. We have quite a wide variety of coils and quite a wide variety of shells. Most of them are black, some of them are white, like this one here. These coils that we looked at are being soldered onto a base that will be assembled inside a shell. The spring tab will be formed, and it'll become the feed point for an antenna. We have a great setup now for soldering the tops with a robot. You can see right here there's a robot soldering a bunch of coil tops. It's applying the flux. The soldering iron comes in, makes the solder joint. Justin here is working on the wideband. It's a 150 megahertz coil that operates at a wider frequency range than our standard 150 megahertz coil. All of our antenna rods are centerless ground stainless steel antenna rods. Some of them are tapered, like this one here has a 0.100 diameter at the bottom and about a 0.070 diameter at the top. Some of them are straight. This one here is 0.125 straight rod, but everything is centerless ground. There's an understanding that when they're centerless ground, the texture is slightly roughed up, so you can't see it with your eye. And that rough texture causes the air to break up as this is passing through the air on a vehicle, and it cuts down on that wind noise. Here, Roxy is putting aluminum balls on the tip of the tapered rods like we were just talking about. And we've got a machine that's basically a Larsen designed machine that crimps the rod, presses the ball on, and then does a final crimping operation on the ball to make it stay in place. We also do a lot of cutting of the straight rod for a lot of different lengths that are required. Here, Elena is cutting straight 0.100 diameter rod to what looks like about 9 inches long. For one of our products, it requires a 9-inch straight rod. The C&M line, which stands for connectors and mounts, is where all of our coaxial cable is processed and built into quite a few different types of cable assemblies. First, I want to show you our automated cable assembly equipment. We have a machine that processes cable from 0.100 diameter up to a 1/4 inch diameter. We have a pre-feed unit that brings it into the section here that does all the strips for the coaxial cable, and then it brings it over to where the cutters are. Then it brings the cable into the coiling pan. We'll go ahead and tie the cable up into a little bundle and get it ready for the next step in the operation. So after the cable is processed in the cable stripping machine, we will come around to the other side of the line where we're building some cables. We're building one of our cable kits. Standard length is 17 feet, but we've got a 25-footer going right now. We've got an animal mount that's attached to this end, no connector on this end. Typically, the customers will install the connector. Here's another cable assembly built on the cable on the C&M line. It's a mag mount antenna. It still has an animal mount on it, but the red cap, you can't see the mount. It's got an SMA connector, 12 foot of RG58 coax package, and ready to ship out to the customer. So let me take you and show you one of our portable antennas that we're building right now. Also got another portable antenna, a little bit different than the dipped antenna. It's injection molded with a durable plastic. We see we've got an SMA female on this. It's got a helical coil inside of this. When it's finished, it'll be cut to the proper length for it to tune to the frequency it's designed for, and then a cap will be glued on the end of this. This one is KD4, and that means it's going to end up with a BNC connector on the mount end of the antenna. Sergey has soldered the connector end on and a little screw machine part on this end that's going to take a little length of speedometer cable. Now the subassembly is built completely. The speedo cable has been attached to the top insert, and we're going to go into the dipping room and watch how the next step to get it ready for dipping this antenna. The product is now out of the oven. The shrink tube has been shrunk around the coil. Next, the antennas are mounted to a rack and then put in a preheat oven before the dipping process. Okay, time is up. We pull the rack of antennas out of the oven and put them on the dipping rack. The machine is programmed for this product, and it goes in at the prescribed rate. Because of the temperature of the part, that liquid vinyl is sticking to that antenna. If it was cold, it wouldn't be sticking, but at that temperature right now, it is sticking and it's building up to about 30 thousandths thickness. You can see the whole process on this board here, where the three components, the four components went together, they were soldered, the shrink tube went on, it went into the dipping process, and then the material is trimmed away, and either a BNC or a TNC connector is put onto this end. When it's cut to the correct length for the frequency it's designed for, then a cap is glued on the other end. One more product line I'd like to show you is our glass mount antennas. We have a VHF glass mount antenna. You can see the inside coupler is being built right now with the cover over the top. This coaxial cable will be soldered to this circuit board and then cut and then smoothed out flush with a double-sided tape here to attach to the inside of the window. In our next station, I'll show you what the outside of this antenna looks like. It goes on the glass on the outside. Here's where we'll see the other half of our KG antenna, our glass mount antenna. We have a piece of automotive glass for testing. We've got our small footprint and our large footprint design right here. The product that we were just looking at is a large footprint. It's a VHF antenna. Here's a VHF, what it looks like. And when you're testing the product, you can just stick it on the glass and simulate the actual application. Again, I want to introduce you to one of our portable test stations. We've got 3 of these that we can roll around anywhere in the factory. The sample was saved on here at 450 megahertz. So Justin is tuning the production parts to match the sample, and you can see that one was very close. So watch when he puts on the next one, it will be completely out of tune. So it's a few megahertz off. So he's going to adjust the length of the coil lead by stretching on the coil. And oh my goodness, it looks like he hit it right on the money that time. So he'll clip off the excess lead, tighten the set screw, and we've got a tuned coil. Our shipping and receiving area is right over here. Products are brought in to this area here, received, and then stocked in our stockroom shelves. And on the other side we have where the completed product goes out the door, our shipping area. Here, a wide variety of products. We must have 2,000 different products that we build in this factory. The shipping folks are very good at picking out the right size box, packing the product so it won't move around and get damaged, and getting it ready with UPS or FedEx or whatever type of shipment is specified, ready to go out the door. After a product is received, sometimes it goes straight to the stock shelves, sometimes inspection is required. If it isn't required, we have our receiving inspection area right here. This area is equipped with all the gauges and measurement tools to measure a wide variety of components that are brought in to build our antennas. Another area I'd like to show you is our tool room. We're equipped to build prototype parts, to work on production fixtures, create and repair. The equipment repair, maintenance, all happens back here. We've got a CNC machine here, an older mill over here. Over here we've got an old lathe that still works very good and is put to quite a bit of use. And we've got a few drill presses back in the corner back here. Here we have an anechoic chamber, and Curtis is our engineer. He's got a job he's working on right now. What you got going there, Kurt?
Today we're working on a 169 megahertz antenna. So we've got a customer that's probably in Europe or somewhere where they're using 169 megahertz. So they asked to have a design, and this chamber here is one of the tools we use to measure the gain or efficiencies that come out of these kind of antennas. So this particular antenna, I just measured, these are typical values, and this is what our customers are looking for as far as the gain and or what we consider called a pattern. So this is what's called a dipole antenna, so it's dipolar, so it'll actually look like you blow up a balloon and you push the little pins, and that's a typical dipolar shape. So ideally what you're looking for. So these colors here represent the gains, and over here on these edges here you see the correlating values of the gain values that come up with this thing.
You got a power test chamber too, I understand.
Yeah, another piece of equipment we use over here. This is a power test chamber. It'll absorb up to 200 watts. One of the devices we use here, this particular piece of equipment here, is 200 watts, which is quite a lot of power. So between the frequency ranges of 400 and 1,000 megahertz. When you do a power test, it needs to be in one of these little boxes or chambers to absorb all the energy, because you don't want the energy to be going out. 200 watts will disrupt the local services, fire departments and whatnot. So they like it if we're doing this kind of testing, that it be in a shielded chamber, which is what this box here is. It doesn't require any real mass to it. It just needs to have the proper shielding to absorb these kind of energies.
Thank you for joining me on a tour of our Vancouver facility located here in the Great Northwest. Come out and visit us sometime. You can start by visiting our webpage at www.PulseLarsenAntennas.com, where you'll find our contact information and a great listing of the products we offer. Our team knows antennas and is prepared to help you with your antenna application needs.